So here in Vancouver Island and on the west coast of Canada, we have both the seismic network and we also have a GPS network. The seismic network is used for measuring earthquakes, and from that we get the size, the magnitude, the mechanism of the earthquake. With the GPS network, on the other hand, we're measuring how much the Earth's crust is being displaced before, during, and after earthquakes. From the GPS measurements, what we're getting is both horizontal motion and vertical motion. So how much land is being lifted up and how much it's being pushed. On Vancouver Island, we're seeing the west coast where we are right now being pushed about a centimeter a year in a northeasterly direction towards the mainland, but it's a squeezing, it's not a motion. The vertical motion is a little bit more complicated, and the GPS is not quite as good as that, but we're still seeing a vertical or uplifting taking place as well. When we use our GPS measurements, it's really important that the point we measure to is in solid rock. If it were on top of a building or on a flagpole, we would not be measuring how the earth is deforming. And that is what we're after. That is key to what we need. So it's really important to pick sites that are stable, and we take great care in mounting our monuments in solid bedrock whenever possible. There are times when it's just simply not possible, and we do the best effort, but it's really important to get our GPS monuments and our antennas on solid bedrock, so when we measure these tiny motions, it's actually representative of that region of the Earth's crust. But what's really exciting right now is the technology, because with modern technology, we can just record so much more. The GPS was not around 20 years ago the way it is today. And so all this information with the crustal motion that we weren't able to get as readily 20 years ago, we can now get. So we're learning much more from that, and we're getting these tiny signals that we wouldn't have seen 15 or 20 years ago. So ultimately, all of this data that we're gathering, what we want to do is improve the safety of Canadian infrastructure. So all the data, whether it's from the GPS networks, from the seismic networks, and all the modeling that we're doing, we use that to provide input into the Canadian Building Code. And from that, we get a better infrastructure for Canadians. We get safer schools, hospitals, bridges, and any of the large projects that take place. For example, any mines that are built, any pipelines that are built, these that drive our economy can use these building codes to build better infrastructure.